Hi, hello. For this lesson, we will be going over residual values. Residual values are basically the difference between the actual data point and the predicted value on a line of best fit. If you have not gone over or learned about the line of best fit or how to plot points, how to use a coordinate plane, I encourage you to check those out first because then this lesson will make a lot more sense. So let's dive straight in. If you have a graph with points, as you can see here, and we have a line of best fit, as you can also see here, the line of best fit is in purple. We may want to find the difference between an actual data point, which I've highlighted in orange. I just picked a random point. You can use any point on this line, or sorry, any point on this graph for your actual data point. And the predicted value, which is a point on the line of best fit. If we want to find this residual value, we have a lovely formula for it, which I'm going to write at the bottom. The residual value is equal to the actual value minus the predicted value. And for this formula, we want to basically be using the y value or the y coordinate here. So let's check out the actual value first. So we're going to find the point that represents the actual value on this coordinate plane. We know the actual value is in orange. And so if we want the points to plot this point, we have an x value of 4 and a y value of 5. So this point can be plotted, this point can be plotted with the values 4, 5. And again, if you haven't learned this yet, then I highly encourage you to do so before you dive into this lesson. For the predicted value, we want to find the point. The predicted value is going to be the point on the line of best fit that has the same x value as your actual point. So as you can see, because this orange line, this orange dot here has an x value of 4, we also want to find the predicted value with an x value of 4, and we're going to find the corresponding y value. So we're going to come down here, we're going to write predicted value. That is going to have, like I said, an x value of 4. And we are just going to, for the sake of this lesson, simplify this a little bit. We're going to find a corresponding y value here. That's a little funky. Let's try that one again. It's going to be approximately 2.5. Again, for the sake of this lesson, we're not going to make it too specific. It's not entirely accurate. But for the point of this lesson, we're gonna run with 2.5. And so, as I said earlier, when we plug it into this equation, to find the residual value, we want to use the y value. So the y value for the actual value is this one right here. It's going to be 5. And actually, I'm going to do this in a different color. It's a little easier to see. I'm going to use the corresponding, we're going to use the y values here. So the y value for the actual value is going to be 5, and the y value for the predicted value is going to be 2.5. And again, these are just approximations. So we know that the residual value, if we were to solve this equation, is going to be 5 minus 2.5, which is 2.5. But what does that mean? We come up to this graph. That means that this distance right here, I'm actually going to erase this line here. This distance right here is 2.5 units. That is the difference between the actual value and the predicted value, and that is called the residual value.